and we'll get to example 3. So here's the graph of f of x. And I want to sketch the graph, and I see some new numbers there. I see the 4 that's new. I see a negative, and I see a 0.5. Everything outside is going to be vertical. Everything inside is going to be horizontal. And we have to remember that the x's are lying to us sometimes. So we have to be careful with that. So I see the 4, it's on the outside. I know that's vertical. Will it be a stretch or will it be a compression? It's going to be a stretch. Because what are we multiplying our y values by? The y values don't lie. Y is going to get multiplied by 4. That's what that 4 on the outside is telling us. Inside the negative, well, that's easy. Inside is horizontal. Negative is always a reflection. And the other negative is horizontal. And this is a stretch because the x's are liars. So we are going to multiply your x by a negative and a 2. Because the reciprocal of 0.5, which is 1/2, is 2 over 1. This one I'm going to show a little bit of work. Okay? I'm going to pick some key points. Obviously, this is a starting point. That's really important. I have a nice point here, and I have a nice point there. Sure looks like a square root graph to me. That's been moved. We'll talk about that at the end. So my original points, I'm going to take negative 2 comma 0. I'm going to take negative 1 comma, negative 1 comma 1. And I'm going to take the point 2 comma 2. And those points are going to change. And we have to multiply our y values by 4 and our x values by negative 2. So above here, I'm going to write both of those things down. I like to write, since x's are your first coordinate, I like to write the x first. Just my brain is left to right, kind of. Doesn't matter that I wrote x by negative 2 and y by 4 in that order. But I'm going to do my x values first. So all of my x values get multiplied by a negative 2. Negative 2 times 2, that's going to be 4. Negative 1 times 2, negative 2, that's going to be positive 2. And positive 2 times a negative 2, that's going to be negative 4. So I just took my x coordinates and I multiplied them by negative 2. Now I'm going to take my y coordinates and multiply them by 4. Well, 0 times 4 is still going to be 0. 1 times 4 is going to be 4. And 2 times 4 is going to be 8. I'm going to draw where those points are. So 4 comma 0, 2 comma 4, and estimate where that one's going to be up over there. Now I have 3 dots. I still have to draw the graph. Okay? Some things that are helpful. Visualize what's going to happen. I'm going to take this graph. I'm going to stretch it vertically. Then I'm going to do a horizontal reflection. Flip it over. And then I'm going to stretch it horizontally. If you can visualize all of those things, you might be able to say, from my visualization, I know my graph has the same kind of shape, but it's going in this direction. Okay? Another thing that can be helpful is this was a key point. That's my starting point. That's super important. I put a green box around it. That's this point right here with the green box around it. What happens to it? It went to this point. Put a green box around it. That's my starting point. So that would also tell me I have to, this way, loop up and go in that opposite direction. Okay? So we have the same shape that way.
Those math contests,
Yeah.
I just added in some grade 11.
Perfect.
Added in one grade 12. Some of these I still haven't asked because they're in my IPS subject.
That's fine.
Just ordered.
I'm sure the other ones
could be fine.
Yeah. And then the one with the X is the one that said no, right? Hannah?
there's an X, that means they don't want to do it.
Okay, perfect.
Miguel's gonna start his test in my room, if that's okay.
Okay, awesome. Okay. Perfect. Questions you can circle for this one are 7, 9, and 10. We're going to do a little bit of analysis on this question as well. Okay? The analysis that we're going to do is, how many of you saw that the original graph was a square root graph that had been moved 3 to the left? No, sorry, 2 to the left. And if it was moved 2 to the left, its explicit equation would have been x, x's are large, plus 2. If you know the explicit equation for the original one, you can write the explicit equation for the blue one. What is the blue one? The blue one was this: y equals 4f of negative 0.5x. What does this mean in explicit notation? In explicit notation, this is my rule for f of x, right? Whatever you plug in for the x, I'll put a highlighter around the x. There's the x. It replaces that. So if you had an f of 1, you'd plug in a 1. Okay? This 4 is outside of that. So that 4 stays outside of that. Now inside, I have, I'm going to highlight in blue, I have this inside. That's going to replace the x. So if I wanted to write an explicit equation here, I'd have a square root, and instead of an x, I'd write negative 0.5x. And then I still have plus 2 afterwards. In the function notation, I think we had no problem graphing it. If you were just given this original equation, we might struggle a little bit. But we'll get to that. We're going to combine things together in the end and put that all together. Okay.